Yeah, Meera and Upasna, is it audible to both of you?
Yes, ma'am.
Yes, ma'am.
Okay. We were discussing spherical refraction and we couldn't complete this. So let us just complete this. Lens, we started the formula. This question we didn't complete. Okay. This is a question from 2023's paper. It says that as shown in the figure, a combination of thin plano-concave. See, this one is plano-concave. Plano means one side is plane. Means one is a plane mirror connected with the curved part. So plano, this is the plane part like this, and this is the concave part. Thin plano and a thin plano convex lens also, like this, is used to obtain an image, is used to image an object placed at infinity. So your object distance is infinity, right? For the first lens, your object distance here will be at infinity. The object is at infinity. It is saying the radius of curvature of both the lens is 30 centimeter. Okay. So if you have the radius of curvature of both the lens, you can predict many other things also. This is saying an refraction index of the material for both the lenses is 1.75. Basically, this means that the refractive index for both the lens is 1.75. So N is 1.75. It is saying both the lenses are placed at a distance of 40 centimeter from each other. They are separated by, this is 40 centimeters, right? They both are separated by 40 centimeters. Question says, due to the combination, the image of the object is formed at a distance dash from the concave lens. From this lens, you have to identify. See, what we are going to do, if our object is at infinity, right? We don't know the focus, right? Focus is not given, and we cannot use our simple f is equal to r by 2 because it's not a mirror. It is saying it's a lens, right? All the lenses are present. So for lens, we did a formula, lens maker formula we did. So that will help us calculate the focal length. See, 1 by f1 for the first one will be 1.75 divided by 1 because medium surrounding is air. So divided by 1 minus 1. And what's the radius of curvature? Radius of curvature, this is 30, right? So see, for this plane mirror, what will be the radius? What's the formula? If you remember, the formula is n1 by n2 minus 1, 1 by r1 plus 1 by r2. Correct. C class. Let me write down this first. This is 1 by f is equal to n1 by n2 minus 1, 1 by r1 plus 1 by r2. Now look, for the first one, we have the plane surface. So what will be the radius of the curvature for this plane surface? Yes, Upasna, what will be the radius of curvature for this plane surface? We did it in mirrors when we were doing the plane mirrors.
Infinity.
Infinity, right? See, this will be infinity, and this is R1, which is given 30, which will be negative. So we'll simply have minus 1 by 30 left, right? So 1 by F1 will be 1.75 minus 1 because divided by 1, 1 by minus 30. So F1 will become minus 40 centimeter. Same thing for the concave one, for the convex one, F2 will come out to be plus 40. Same calculation. Right, because one side will again be the plane, but this will be positive, focal length is positive, so you will get the focus. Tell me, is it clear till here? Focus part you've understood?
Yes, ma'am.
Yes, ma'am.
Okay, now let's come one by one. Like if an object is present at infinity. See, class, even we need not calculate this. If you know the focus, do you notice if the object is formed at infinity, where is the image formed? Meera, can you answer? If the object is at infinity,
focus.
where will the image at focus? Exactly.
At
So see, let's say some rays are coming and at the focus, see, this is a diverging lens. So at the focus, they are getting converged. Like this somewhere here like this. This is also coming, and they might get converged at the focus. So first one is very easy. Even if you go by the calculations, even if you perform 1 by v minus 1 by u is equal to 1 by f. 1 by v minus 1 by infinity is equal to minus 30. So here, you know, v is equal to minus 30 centimeter. What is this minus 30 centimeter? Minus 30 centimeter is basically where the image has been made, right? Image is made 30 centimeters in front of it, right? Now the question says, see, these parallel rays were coming. They have been refracted by the first one, right? So you are getting the image one. Let's say you are getting the image one somewhere here. Now this says, what's the focus? Focus is 40, right? So focus is 40. The focus of this lens is 40, means the image was supposed to be formed at 40, right? Now next lens we are going to take with the same parameter. This is going to act as the object for it. Are you getting it? This is going to act as the object for it. Oh, sorry, focus is 40. This is 40. Image is formed 40 centimeter. Now look, this is the first case. Now refractions will occur from the second lens. Now look how we have it. Let me draw it a little wider because this isn't looking like. Let's say here, somewhere here, the image has been formed. So what is this separation? What have we calculated? Object at infinity, image at focus. What's the focal length?
40 centimeter.
40 centimeter. This is 40 centimeter. Now, Meera, can you tell me? Now this image is acting as the virtual object for our second lens. First lens we have solved, we have got the image also. Now, Meera, can you tell me what will be the object distance for the second lens for this object distance?
80 centimeter.
80 centimeter, exactly. And sign, positive or negative?
Negative.
Negative, right? So see, this is what we were discussing about the virtual images and virtual objects. This is what is our object distance for the second lens. Now we are referring to the second lens. This was the first lens. We need not even calculate this. You knew if it is formed at the focus, image will be exactly at minus 40 centimeter. For the second lens, object is formed at minus 80 centimeter. Means this is not a real object. It's the virtual object as it is formed because of the first real object, right? Real object casts a real image. If that real image acts as the object, we say this is the virtual object. So virtual object is placed at minus 80 centimeter. Focus. Focus is 40 plus 40 centimeters. So let's use the calculation of V will be minus 80 into 40 divided by minus 80 plus 40. Minus 80 plus 40. This will also come out to be 80. This will be 80 centimeter, but this is not my final answer. Now see, here, this is acting as the object. The rays have, let's say they have strike this. Now somewhere we are getting the image as, is it positive? Yeah, we are getting this as positive. Okay, this is the final image that we have, let's say I. This is what? This is 40 centimeter what we are getting, right? Upasna, tell me what will be the answer to this question? We've solved everything.
$120 centimeter.
Yes, very good. The answer will be 120 centimeter because question is saying from the concave lens. This is your concave lens. This was your convex lens, right? So from the concave lens, this is 40 And we are getting this as 80, right? So 80 plus 40, that is total is 120. So answer will be total distance that you will take. The final answer will be total distance from concave will be 80 plus that 40 centimeter gap between both the mirrors, which is 120 centimeters. Got it, both of you?
Yes, ma'am.
Yes.
Please write down this properly, and then we'll come to the last part, optical instruments.
Done.
Done, ma'am.
Done, both of you?
Yes, ma'am.
Yes, ma'am.
Okay. See, now coming to optical instruments. Okay. So this is the last part of your ray optics, and let us start with the wave optics then. So see, optical instruments do not have any much difference from your NCRT part, and a different formula will not be used here. Most of the different formula were there in your plane mirror. So please practice plane mirrors well. Okay, see, optical instruments, when you have to calculate the angular magnification is basically the ratio of the image when it is subtended without the lens. Like if without the lens, you're seeing an object, divided by when the object is placed at the image position with the lens. So see, here the important part that you need to remember is, see, we'll be doing two types of devices. You have microscopes and telescopes. In microscopes, you have two kinds. One is the simple microscope, second is the compound microscope, right? So when we're talking about the microscope, for the simple microscope and compound, for all the microscopes, we have two cases. One is when the image is formed at least distance of distinct vision, that is 25 centimeter. Least distance of distinct vision will also be given. Least distance of distinct vision means you are able to see without the lens. Like this is a specify remove it. Without the lens, if you are able to see an image clearly, this distance is 25 centimeters. So if you're able to see the object clearly, this distance is called as the least distance of distinct vision. Before it, I'm not able to see it clearly. Afterwards, it becomes 2 and I'm not able to see it. So that distance where you're able to see the things clearly, this is called the least distance of distinct vision. Okay, so that is important. Now, when the final image is formed at D, D is this only. The formula of magnification is 1 plus D by F. For when the final image is formed at infinity, M is equal to D by F. These are the two formula for the simple microscope. Then you have the compound microscope. This we have already discussed, that when the magnifications are multiple, you just multiply the individual magnifications, right? So here L is the length of the tube. Length of the tube means the separation between the eyepiece and objective. This is what is meant by length. Length by FO. FO means the objective length. See, in a microscope, how do you identify it's a microscope or not? Microscope basically has a smaller objective piece and a larger eyepiece. And in case of telescope, you will have this objective piece larger and the eyepiece will be smaller. That is how you can identify. So small aperture of objective lens. And then you can reverse it for the rest of it. Now, this is the formula. M is equal to L by F naught, 1 plus D by Fe, or you can use V by U also. Same formula, you can apply. Same thing. Instead of L by F naught, you can write V by U. Same formula. Then final image is formed at D. This will be L. This is we have discussed. Final image formed at infinity. M is equal to L by F naught into D by Fe. Or you can simply use V by U into D by Fe. Same thing. Instead of L by F naught, you can replace it with V by U depending upon whatever is the case. Then resolving power is 1 by D. That is, we write this as 2 divided by 1.22 angstrom. 1 angstrom is 10 to the power minus 10. This is written a little clearly below. So just leave this right now. Then let's see the astronomical telescope. So in the astronomical telescope, you have the two equations where the image is formed at least distance of distinct vision. This is when image is formed at D minus F naught by Fe. See, you can see this is the objective, this is the eyepiece. Here the objective here the objective lens aperture is more. Just a minute. I'm resharing the screen, okay? It was lagging a bit. Just wait. Is the screen visible?
Yes, ma'am.
Yes.
Okay. Then when the image is formed at the infinity, we use minus f not by f. So these are the formula from your basic NCRT portion. Just a little extra, just in case if it comes. This is what I was talking about. So the eyepiece of Galilean telescope, this is 1 by d by f. Resolving power of microscope is d by 1.22 lambda. Resolving power of telescope is minus v naught by u naught 1 plus d by fe. Magnifying power of simple microscope is 2. The refractive index sine theta by lambda. Magnifying power of compound, this you leave. Okay. So see, when you have the resolving power of microscope, resolving power of, this is actually a match, the column. Okay. So when you have the resolving power, when you put the resolving power of telescope and the microscope, from here, let's do this, match the following only. First one, eyepiece of a Galilean telescope. So it's a concave lens or a convex lens. Okay, Galilean telescope we have not done. We have done the astronomical telescope. So that will be the concave lens. Okay. When we're talking about the resolving power of microscope, see, magnifying power of simple microscope, magnifying power of compound microscope, these are the normal formula of M. See, for the fourth part, this is what we have done for the simple microscope. And this is what we have done for the compound microscope, right? So for the telescope, this is this formula which I was telling you here. This is the same formula for the resolving power of the microscope. So this is the exact same formula here. So in this, just focus on these two columns. That's why I've put this. Forget rest of the things. Just focus on this is the formula which you need to mention. And for telescope, just mention this formula. Okay, so just write down these two. That's it. Don't write anything else. Just write these two. Then we'll discuss the questions. Okay.
Done, ma'am.
Both of you.
Yes, ma'am.
Okay, start with this question. There's two questions we have to discuss, this one and this one. First, write down this. Okay, class, let's discuss it now. So this says that yes, am I audible? Is it
Yes,
audible?
ma'am.
Okay. See, this says that an object viewed from a near point distance of 25 centimeters using a microscopic lens of magnification. So magnification is given as 6. Near point, this is capital D only, which is 25 centimeters. So this is the separation. Magnification is D, gives an unresolved image. A resolved image is observed at infinite distance with total magnification double the earlier using an eyepiece with the given lens and a tube of length 0.6 meters. See, length of the tube is 0.6 meters. You can write this as 60 centimeters also, because the rest of the things that will be given to you, the rest of the things are in centimeter, right? Focal length is also in centimeters. So what all things we have? We have the magnification, that is 6. Object is viewed from the near point of 25 centimeter distance. This is also present. And the length of the tube is given as 60 centimeter. That is 0.6 meters is given. We can take this as 60 centimeters. So it's a question, okay. Now see, we have to first find out what's the focal length of the objective lens. That is also not mentioned in the question. So simply we are going to use the magnification formula for the microscope. So magnification is 1 plus t by f naught. Rest of the things are present. Magnification, you know, d is already given and you already know d, that is 25 centimeter. Even if d is not mentioned, you have to take this as you already have to take this as 25 centimeters. So magnification is 6 plus 1 by 25 divided by FO. So this will be 25, this is 5. So 5, right? F naught will be 25 divided by 5, which is 5 centimeter. So you have the focal length of the objective lens now. Now we are going to use the formula with the length of the tube. So magnification is length of the tube by focal length of the objective lens into D by FE. From here, FE is only missing, that we have to find out. What's the magnification given now for this, for the compound microscope? Yes, tell me from the question for the compound microscope.
36, 12.
12, right? Double. This is 6, so this will be double, correct. So this will be 12 is equal to L is 60, let's take. FO came 5, D is 25 by FE. So we can resolve this. This becomes 5, 60. So it will be, length of the tube is 60, right? So 12 is there, 5 is there. So how much will it come? This is 25, right? This is 25, 60, 5 and 12. Yeah, this will be 25 only, correct? This
Yes,
will
ma'am.
be 25 centimeters. So 25 centimeter is the answer, because 1 here, this will be divided. So 1 is equal to 25, that is 25 centimeters. Write it, then this question we will discuss.
And
Okay, class. So this question says, in a compound microscope, the magnified virtual image is formed at a distance of 25 centimeters from the eyepiece. The focal length of its objective lens is 1 centimeter. Okay. So see, D is 25 centimeter. Focal length of the objective lens, this is given as 1 centimeter, and again the length of the tube is given as 20 centimeter. So we will have to calculate FE. So it's a similar question from your 2020's paper. So first of all, when you are calculating, right, now first of all, when you're calculating, you have to calculate the magnification of the compound microscope. So we have just done the magnification. What's the formula in terms of length of tube? Huh? L by
L
F
by
naught
F
1
into
plus
1
D.
plus D by Fe.
Yes, this is the formula. Please revise the formula of the microscope. So L by F naught 1 plus D by Fe. So from here, we can at least calculate Fe. Fe is unknown to us. We can at least calculate Fe. D is given. F naught we have. Length of tube we have. Okay, magnification. Magnification is also not known, right? Magnification here is missing. So we will have two variables. Magnification will be 20 divided by 1 plus 25 by Fe. So we'll have variables here, that is magnification is not. Now here the magnification is, it is saying that if the magnification is 100, then the length of the tube is 20 centimeters. So directly let's put the magnification then. In a compound microscope, the magnified virtual image is formed at a distance of 25 centimeter from the eyepiece that we have taken. Focal length of the objective is given as 1 centimeter. If the magnification is 100, this is saying if the magnification is 100 and the tube of length microscope means the tube length of the microscope is 20. So let's put it as 100 magnification is given as 100. So this will be 100 is equal to 20, 1 plus 25 by Fe. So this you can calculate now. What will it be? Right, this calculate, tell me what's the value of Fe coming. Write it and just let me know, then we'll start with wave optics. Right, 6.25, 25 by 4 you will get. So it will be 6.25. Correct. this will be 5 is equal to 1 plus 25 by FE. So this will be 4 is equal to 25 by FE. FE will be 25 by 4, which is 6.25 centimeter. Right. Quickly write it. Just let me know done.
Done.
Both of you, Meera? Okay, Meera already answered, so she must
Yes,
have.
ma'am. Done.
Okay. I'll share this PDF right now. Okay, after the class gets over. Okay, now from your wave optics, the important topics I have written here first. Important topics are the wavefront and the Heinz principle, interference and Young's double slit experiment. See, from 2020 to 2025, YDSE has come every year. So YDSE is very important. Then you have some questions on thin film interference. We'll see, we have taken one question that we'll discuss. And polarization, see, it is deleted from your school syllabus. So polarization, but it comes in the JEE exam. So we'll be discussing that. And then diffraction, this will be the last topic. So these are the important topics that we have to discuss. Now, starting with this wavefront, concept of wavefront, what is a wavefront? So a wavefront is the continuous locus of all points which are in the same phase. Basically, what is the meaning of this is, see, this is, let's say, the centralmost locus. Okay. Now, when a wave is getting radiated, what were the points that were emerging? So see, we have not done the dual nature chapter that time. Tomorrow we'll complete modern physics unit. So we'll discuss that time also. Wave particle also exists in electrons and the particle nature also exists. So many of these said that all the rays travel like this. Right? Like this. The rays, this is how the rays are traveling. But some of them said that no, the particle nature also exists. So these will be having the particle nature also. And the wave nature means along with the particle nature, these waves are also present. Right. So what exactly is a wavefront? It was finally concluded. Wavefront, it is said that continuous locus of all points of particles which are of all points which are in the same phase. Means it was finally concluded that no, this isn't what happens. They are spreading out. The wavefronts are spreading out in all the directions together. Like the water ripples. If you look at this example, if you drop a pebble in a water, in a pond or a lake which is stagnant, and when you drop the stone at it, what happens? These ripples are created like in the form of circular, and all these ripples, they travel along these concentric circles and spread out. So it was observed that no, this isn't the theory, this isn't how the wavefronts will move. The wavefronts are actually how the particles are traveling, so they will also be traveling like this is what is meant by a wave. Like, see, if you imagine there's a stone over here. So all the water droplets together in a continuous location. So continuous locus means this only. All the particles are now continuously moving and simultaneously they are in the same phase moving. So like concentric circles they are. This is what is meant by a wavefront. And what will be the direction of wavefront? See, wavefronts, one more thing, rays will always be perpendicular to the wavefront. Rays will always be perpendicular to the wavefront. Second of all, if the direction of propagation is like this, see, you can see the waves. These are the direction, these are the waves. They are propagating forward like this, the waves are propagating. So wavefront is perpendicular to it, like this. See, you can see this line. This is the direction of the wavefront. Then there are various types of wavefront. See, depending upon the source. If the source is like a pebble, so in case of pebble, when you throw a pebble in water ripples are created in the form of concentric circles, right? So similarly here also, when you have different kinds of sources, that will create a different kind of wavefront. So spherical one is very easy to relate with the pebble case, right? So spherical wavefront when you have the source as a sphere. Here, the source is a sphere or a point. So like this, these wavefronts are created. See, these are the wavefronts. And these perpendicular ones, what are these? Can anyone tell? These perpendicular ones.
Rays.
Rays. Very good. The perpendicular one are the rays. So this is how you have to locate rays. You have studied ray optics is over, so you know how to locate the rays now. See, instead of, if I just have one circle like this and one point source, I have this. If I join multiple point sources like this, one source, then one source, then one source together, it will form a straight line. What will happen? Around every point, there will be circles like this. Around this point also one circle, around this point one circle, like this, like this, like this, it will form a cylinder. It's like if you take one point here, it is also having a wavefront like this, where the rays are spreading out like this. So if you have, it's like the piles of coins, right? If you have a pile of coin is there and you have stacked up all the coins, it will give you a cylindrical look. But if you look properly, every slice is of a coin, right? So that is what is a cylindrical wavefront. Here the source is linear like this. This is the source. So it is giving a circular wavefront for every point, and in total it is giving a cylindrical appearance. If you have a plane wavefront, then the lines are perpendicular to it like this. So is it clear, the wavefront part?
Yes. Yes.
Okay, now you have some special cases where your mirrors and lens are related with your wavefronts. So see, behavior of plane wavefront in a concave mirror or a convex mirror. So this is how it is seen. Few questions come directly from prism, concave mirror, convex mirror, and the rest of the mirrors. So if you have a concave mirror, this is how the rays are formed. So from this point, if you start drawing the wavefronts, this is how the wavefronts will look like. This is a convex mirror. See, this is a convex mirror. Convex mirror does what? It reflects back the image, right? It diverges the image. So see, if this is the virtual image that is formed, this is how you are going to form the wavefronts. Perpendicular, just draw perpendicular to the rays. Like if a ray is present like this ray was present here. So at this point, we have put your compass like this and you are going to draw the spheres like this. Then for convex lens is going to converge all the rays. So this is how the wavefronts are going to appear. Similarly, this is a concave lens. See, concave lens diverges. So this is how the wavefronts are going to appear. What you have to do, you know how what is the function of a concave mirror, what's the function of a convex mirror, concave lens, convex lens, right? So you form the normal image. See, first you form this image. Then from this point as the locus, see, if I complete this, this will be one circle. This will be second circle. This will be the third circle. Correct? So I've just drawn a portion of it. Like this, if this is your final image formed, see what will be. This will be the wavefront. This will be the second wavefront, third wavefront. So that is what is written in points like this. If this is your final image, you just have to see where your final image is formed. Like this is your image. So wavefronts will be formed around it like this. Did you understand why these small curves are present? Understood?
Yes, ma'am.
Just complete the circle. You will yourself see that, yes, this is a part of the wavefront. See, this will be also the part of the wavefront like this. Then prism. Prism case also comes in the exam. So in prism, see, you have a plane wavefront. This is a plane wavefront. So at every point the rays are coming, they are getting refracted twice. Once the refraction occurs at this surface, second the refraction occurs at this surface. So you get a refracted wavefront. For every point it gets refracted like this. So if this is the plane wavefront, this becomes the refracted wavefront. How? A, for A point, it will move like this, it will go like this, and it will bend like this, A dash. For B, it will go like this, then like this, then like this. Like I'll show you. This is for B point. It will be refracted and it will again be refracted. So for every point you will finally obtain like this, all the points will be present. When you join all these points, you will get the refracted wavefront. Is it clear the concept of wavefront?
Yes, ma'am.
Okay. Coming to the High-Ends principle. What does High-Ends principle say? So what does the High-Ends principle say is basically every point on the wavefront acts as a fresh source of new disturbance. See, this means that let's say there is a source. This is the main source. Okay. And this has created some wavefronts. This is the main source and this has created some wavefronts. Let's say this has created a wavefront. Main source. I'm just showing you a portion of it. What is this called? This is called a primary wavefront. Primary wavefront, or we also use the term wavelet. Primary wavelet for it. Now, what is Heinz principle saying? That every point, see, we said initially that these are not continuous just curves or straight lines. These are a collection of points. So if you see every point, like if I show you one point is here, all the points are continuously in contact with each other. Just for the drawing purpose, I'm showing them at a separation. They all are together, like how a wave is formed. This is your wave optics. So we are focusing on waves. You're not focusing on the particle nature. So this is how the waves are formed. Now what happens? This is saying that every point is acting as a new source of disturbance. Means this is also acting as a new source. If this is a source, one wavefront will be created like this. If this is a source, another wavefront will be created like this. So you can see the wavefronts are created. This is what is according to Heinz principle. That if you have the source is present, primary wavefront is present, primary wavefront will create, every point on the primary wavefront will act as a fresh source of disturbance. So main source was there. Now you have new sources and these new sources are creating new wavefronts. Now you have these are called as the secondary wavefronts because these were not originally formed. They are called as the secondary wavefronts or wavelets. Now, how do you get the new wavefront? Just join their tangential surface. That forward envelope which you can see of every source, all the forward envelopes, just join them with a straight line. Tangential to it, tangential to this, like this, then tangential to this, like this. See, the wave has actually propagated. Now what will happen? Now on this wave, each point which is present will act as a new source of disturbance. This will create a new source like this. New sources will be created. Again, we'll join there by forward envelope. Again, these will act as a fresh source. So what is eventually happening? You are having the you are seeing the propagation of wave. Can you see the waves are actually moving now? Here it was near the source. Now it is actually traveling like this. See, it will again act as a new source. Like this, it will keep on moving. Yes or no?
Yes, ma'am.
So Heinz principle basically tells about the propagations of waves. And these wavelets travel with a speed of light, that is 3 into 10 to the power 8 meter per second. So this is what is written. Let's read the points. Each point on a wavefront acts as a fresh source of new disturbance called the secondary wavelets or waves. These secondary wavelets spread out in all directions with the speed of light in the given medium. The new wavefront at any later time is given by the forward envelope. How is this forward envelope formed? By the tangential surface in the forward direction of the secondary wavelets at that time. Is this clear, Heinz principle? Is it clear to all of you?
Yes, ma'am. Yes, ma'am.
Okay. Now, before starting with interference, you should know two kinds of sources exist. One we say coherent source, one is an incoherent source. So you need to focus more on the coherent sources that are there in your syllabus. Coherent sources means the source that emit waves. Right? Sources are what? Sources are emitting waves. Like our source in ray optics was the object. Object was the one which was emitting source of light. So source means the coherent source, or the incoherent source means when the sources, two sources such, there are two sources, let's say S1, S2. These two sources are such that the waves that are propagated by them, let's say one is by this, second by this, they both are traveling in the same phase with the constant phase difference, same wavelength, same frequency. We will then say these two sources, they are the coherent sources. And if such not happens, so see, let's read the definition. A coherent source is one that emits waves like light waves that have a constant phase difference and the same frequency. Same wavelength, same phase difference, same frequency, everything is the same for coherent sources. An incoherent source emits light waves that lack a consistent phase relationship. No phase difference. Constant means phase difference will be there, but it won't be constant. It will be changing with time. And they may have different frequencies, wavelength, phases, and are not in sync. Got this?
Yes.
Okay. Let's start with this process of interference. Now, interference basically means superposition of two waves. Interference is there. This is a part of your 11th classes wave optics also. So what does this say? When two rays are present, two or more coherent sources have to be existing. Okay, coherent sources have to exist for interference to occur. Interference basically means two sources are there. They are emitting their waves, and these waves have coincided to form a new wave. This is what is interference. For the definition part, definitely you can refer to this. When two or more coherent waves superimpose in a region, then total wave energy in space is redistributed. This phenomena is interference. But in simple terms, you should understand, like if two sources are present, let's say two sources are there and they have emitted two waves. These are the two waves. These are the two sources. Okay, two sources are present. They have emitted two waves. Now these waves have superimposed on each other. So this process is called as interference. Now there's a formula of intensity which is very important. Intensity is 2 pi square f square a square rho e. What is f? F is the frequency. A is the area. Rho is the density. V is the volume. This is an important formula. Directly formula-based questions have come from this. Okay. Then intensity is directly proportional to square of the amplitude. I is directly proportional to a square. So you have two waves. Y1 is equal to a sine omega t minus k x1 plus phi 1. Y2 is equal to b sine omega t minus k x2 plus phi 2. Now we are going to see the conditions here. Two waves, these are the two waves which have superimposed according to us. Now what is this? A and B. These are the amplitudes. A and B are the amplitudes of the wave. So what it's like, let's say this must be some y1. Let's say this is y1. Y1 is moving, this amplitude is A. Then another wave comes, that is B. B starts moving like this. So this amplitude is B. This process is called superposition, that is interference. This phenomena will be termed as interference. Okay. And the resultant amplitudes will also coincide and will give a different thing. So new phase difference will be there, new resultant intensity will be there, new resultant amplitude will be there. Got it till here before we come to the discussion of the numericals?
Yes, ma'am. Yes, ma'am.
Okay, now let us see few formula, then we'll come on to the numericals. For the phase difference, use the formula k x2 minus x1 plus phi 1 minus phi 2. Okay, if you see phase difference is constant in your coherent sources, because you can get incoherent sources just in case. So for that, you use this. If both are equal, then both of them are equal, then you say phi is k delta x, where your k, if you remember, we already have discussed this in the EM waves, 2 pi by lambda, angular wave number, where your lambda is the wavelength. Okay, now net resultant R means the amplitude. See, if two waves are meeting, like let's say amplitude of A was very less, amplitude of B is greater, you can see Y2 is greater, B is so huge. And for the Y1 wave, amplitude is so less. But still, when you add it cumulatively, somewhere here, the resultant might be there. That resultant's amplitude is given by under root a square plus b square plus 2ab cos phi. Now, as discussed, intensity is directly proportional to the square of the amplitude. This is important. In general, also, this formula is important. So, resultant intensity becomes I1 plus I2 plus 2 under root I1 I2 cos phi, where phi is what their phase difference. Now, two types of superpositions take place. One is constructive, other is destructive. Now, what is this constructive? In constructive, what happens? Suppose two waves are there. Let's say this is one wave and this is another. I'm just drawing a very small portion of it. This is the crest, this is the crest, this is the trough, this is the trough. If you see, such waves are coinciding, they are getting superimposed. So what will happen? See, both are in the same phase, they are in the same direction. Amplitude is also rising. It will result in a greater amplitude like this. So this is called constructive interference. Everything will be maximum, everything will increase, everything will be added up. So net amplitude, R means the resultant amplitude. R net and I net. I net means the resultant intensity. They'll be maximum. Cos phi will have the value 1. Phi will be equal to 2n pi, where your value of n will lie from 0 to 1, 2, 3 and all you can exceed. Maximum amplitude will be A plus B. Maximum intensity will be under root I1 plus under root I2 whole square. Because you put cos phi as 1, you will get the same thing. So why not to remember it directly from here? Right? Then you have the destructive interference. In destructive interference, what happens? If a wave is like this, crest and trough, but the other wave is like this. First the trough, then the crest. This is called as destructive interference when the waves superimpose each other. Okay, so what will happen? Both are in opposite. They are in opposites. This will result in a lesser of amplitude. Everything will be minimum here in destructive interference. Amplitude intensity will be minimum. Cos phi will be -1. So phi's formula becomes 2n plus 1 pi, where your n lies from 0, 1, 2, 3 and all you can exceed. R minimum will become A minus B and intensity minimum will become root I1 minus root I2 whole square. Tell me class, is it clear till here?
Yes, ma'am.
Okay, before starting with the questions, just write down few things. You have not written anything, no? Wavefront is, I'll share, you will be able to relate. Heinz principle is also. Yeah, write down this intensity. Written.
Yes, ma'am.
Rest, I think you will need the intensities formula. Just write down this amplitude and this intensity is resultant. This will be needed. Write down these two.
Done.
Done?
Yes, ma'am.
Okay, let's start with. Okay, this part also you have not written. Just write down this constructive and destructive also. Because this maximum and minimum, we are going to use it in this coming question only. Write down this page and just update me. Done.
Done.
Done, ma'am.
Okay. Let's start with the question. See, this says that in an interference experiment, the ratio of amplitudes of coherent waves is A1 by A2 is 1 by 3. So basically it means that if the first one whose amplitude, let's say A is 1x, A2 will become 3 times x, right? Just putting the constants. Now it is saying ratio of maximum and minimum intensities of the fringes will be. Then directly let's write the amplitudes, the intensities only from this. Look, intensity and amplitude, how are they related? Yes, class.
Directly proportional to amplitude square.
Yes. Intensity is directly proportional to square of the amplitude. Correct. So if we are talking about these amplitudes, look, if the first one is A, so intensity, let's say, is I. It will be I only because 1 square is 1 only. But if amplitude becomes 3 times A, intensity will become 9 times I. Did you understand this?
Yes, ma'am.
Using this only,
Yes, ma'am.
amplitude square will be intensity. If this is 1 into A, this is actually 1 into A because this is 1. So this is I, this is 3 times it, so this becomes 9. So you have both the intensities with you. I1 is I2 is 9I. Or you can use some constant K or X also, same thing, everything. These things will be cancelled because it's the ratio. Now you have to take the ratio of maximum to minimum. C class. I maximum will be, see, what will be I maximum? Maximum will be root 9I plus root I whole square. Check, this is the formula of the maximum from constructive you've written, right?
Yes, ma'am.
Yes.
Divided by. Yes, so Pasna, tell me what should I write for minimum?
Root 9I minus I the whole square.
Correct. Root 9I minus root I whole square. So this will be 9. This is 3 plus 1 and 4. Then that is minus 1, 2. It will come 4, right? Just check. Write down this, then we'll see the next question.
Done.
Done, ma'am.
Okay. Let's move to the next question. Okay, the options are written here. The light waves from two coherent sources have same intensity. I1, I2 is equal to I0. In interference pattern, the intensity of light at minima is 0. Means minimum intensity is 0. What will be the maximum intensity? Yes, class. Try this. Tell me how should we proceed? Just tell it here only. If minimum is 0, it is saying I minimum is 0. And it is telling us I1 is equal to I2, which is equal to some I0. Try it once. Answer is very simple. And it's better if you remember the result of this answer too. Yes, class. By now you should get the answer. What is the answer? Tell me the method at least. Yes, Upasna?
Is it 4 I not?
Yes, correct. It will be 4 times it. See, why minimum is 0? Even if it doesn't tell about the minimum, it's okay. If both are equal, it will be 0 only. Because root I1 minus root I means root I0 minus root I0 will be 0. So we know minimum will be 0 if they do not tell us. This is asking us maximum. So maximum means root I0, this is square also, plus root I0 and you're adding it. So this becomes 2 root I0's whole square. So this is 2 square is 4, I0 is I0. So answer is D. Try to remember this answer also because this has come a lot in the previous year questions. Write it. One more question we'll see if, based on this intensity.
Done, ma'am.
Both. Okay, this says two coherent sources, light sources having intensity in the ratio 2x. This is 2x is to 1. This ratio is actually 2x is to 1. Produces an interference pattern, ratio of I max minus I min divided by I max plus I minimum. See, this is the ratio 2x is to 1. This is the ratio of what? Ratio of the intensity only. It is not the ratio of amplitude that we need to change it. This is what is the ratio of the intensities. So you can take one as 2x, the other one will become x, or take one as I. Take instead of x, you can take it as I also, but I think in the option it's given as x. Let's take it as x only. So your one intensity will become 2x, second intensity will become x. So what will be I maximum, Mira? Yes, Mira?
Root 2x plus root x whole square.
Yes, correct. This will be I maximum. And I minimum, Mira, you only tell for minimum?
Root 2x minus root x the whole square.
Root 2x minus root x to the power whole square. See, this is simple to solve. Look here. We just have to take the differences between these two and then we have to add it. This time, instead of telling you that I maximum by I minimum, usually the question says no, I maximum by I minimum. Right now the question is saying you take I maximum minus I minimum. So in this question, you take x out, root x is there, right? You take this out, root 2, x is present. Or you can take this as I also. So from here, root 2 x, root 2 whole square x will be left, right? From here. And from here, the same thing, root 2x minus root 2x if you take. So if you take x out, so your root 2 will be left, right? So if we add it, your final answer will be root 2x plus root x whole square minus root 2x minus root x whole square divided by same thing with a positive sign, right? Root 2x plus root x whole square minus root 2x, this is plus, minus root x whole square. Solve it, see which answer you're getting, which option. Write it. Let me know the option out of A, B, C, D. Then we'll do the theoretical part. Written. To solve this question, just take this out for individual. See, this is root 2 into root x. So root x whole square can be taken out of the bracket, then solve it. Otherwise, if you solve this whole big bracket, it will be difficult. So your option will come D option. Done?
Yes.
Meera, done?
Yes, ma'am.
Okay, let's start with Young's double slit experiment. So basically in Young's double slit experiment, there was a source of light and two slits were drawn. From both the slits, waves were entering and they used to superimpose each other. What happened? Two kinds of patterns were observed. Bright and dark fringes were observed like this. Yeah, like this. See, a bright fringe, then a dark fringe. So in the center, we used to get a central maxima here, this part. This is the central maximum. Maxima means, see, two waves are coinciding, so they are constructively interfering. So that gives you this lighter colored portion, and then you have these darker portions. Then light. So basically, if this is the central maxima, this becomes the first dark on both the sides. First dark. Then see, this will become first bright on both the sides. First bright, first bright. Then again, you have first dark, then you have second dark, second bright, like this. This will move on. See, this is the first bright. This becomes the second dark. So this will also be the second dark. Then you have the second bright. Then you have the second bright, like this. This is how these wave patterns are formed and they are constructed. Okay, now the separation between the slits is taken as small d. Small d is the separation between the slits. So that formula part, we'll do it here. But first, you need to understand what are these. These are basically the slits. This is the slit. These are the two slits which are done. One here from where the wave is going and one here from where the wave is going. This is the source. Monochromatic light source. Monochromatic means only one. Monochromatic means one wavelength, one frequency. These are in any ways your coherent sources. So one light is only used here. They are moving like this. Separation between the two slits is small d. And separation, this is what? This is your screen. So separation between your screen and your slit is capital D. So like this, the two waves coincide at a point, they give you fringe, and this whole pattern is observed. Till here, is it clear? Formula part I'll show you again. This is clear?
Yes,
Okay.
ma'am.
Now coming to the bright fringe, the entire story about those white parts which you are able to see. Those are the path difference for these. See, the delta x means the path difference. Path difference means that, see, if two waves are moving, they may not be exactly of the same length. Like if I say these are two waves, okay. One is coming from a source which is nearer to this horizontal line. So it is of this length. Another one is this long. Okay, let's say this is only this. This one is this long. So can you see this extra portion here? This extra part here, which is extra. Look, this part is extra. Till here, both the waves are of same length. But this part is extra in this wave. So that is the path difference. Similarly, the angle is different. That is the phase difference. So we write this as bright fringe. This is written as n lambda. Okay, for bright fringe, and the phase difference is written as 2n pi. Now y is equal to n lambda d by d. What is this y? Y means the separation from the central maxima. Like if I obtain a fringe here and I want the entire detail about this fringe. Let's say this is the bright fringe and I want to obtain. So separation of this bright fringe from the central maxima. This is termed as y. So I'm writing down what is the meaning of the variables. Delta x, this is the path difference. This is the path difference. For dark fringe, it becomes 2n minus 1 lambda by 2. For bright fringe, it is n lambda. For this is the phase difference. So here the phase difference becomes 2n minus 1 pi. This is simply 2n pi. This is 2n minus 1 pi. Y is the separation of the fringe from central maximum. Okay. CM means the central maximum. And what is this capital D? Separation between screen and slit. Separation between the screen and slit. And what is D? It's the separation between the slits. So this is the separation between the slits. Okay. Is it clear till here? What is the meaning? Any doubt? Because see, I did it very fast because you must have done it earlier. So as a revision, I have done this very quickly. So you tell me if you want me to repeat anything in detail or just explain anything. Is it clear?
Yes, ma'am.
Yes, ma'am. Clear.
Now, fringe width means width of the fringe, and angular fringe width means what it is subtending, the angle that the fringe is subtending. See, fringe width is very clear, lambda d by d. Fringe width means if this is a fringe, this must be subtending some angle here, this angle. This angle would be theta, that is your angular fringe width, which is beta by capital. 3 to 4 questions we'll be doing from Young's double slit only holds the largest weightage. From here, just write down this part, bright and dark fringe, because then let's start with the numericals.
Done, ma'am.
Done.
Okay, let's come to the numericals. So this is a question from 2023. Have you seen the recent papers, JEE papers, which are ongoing? Every question, most of the questions are from your NCRT only. 2nd April's paper, if you see, both the shifts papers were from 1 or 2 questions, which I told you that remember the susceptibility formula, chi m and susceptibility formula, that also came as it is for one substance. Have you revised that table? I told you to learn it. Is it yet to be revised or learned? Yes, Upasna, Meera. Not
Ma'am,
revised.
I have to revise that table.
Okay. See, this says in Young's double slit experiment, the position of the 5th bright fringe from the central maxima is 5 centimeters. Distance between slits and screen is 1 meter, and the wavelength of used monochromatic light is 600 nanometer. Separation between the slits is, first of all, what it has given to us still. Upsana, you tell me. See, number of the bright fringes, N is? Yes, Upsana?
5.
5. Yes. And Upasana, you only continue. You tell me this. What is this 5 centimeter? Yes, Upasna. What is this 5 centimeter out of all the variables which you have written in your register? Check.
Y.
Y, right. See, separation of any of the fringes from the central maxima. If this is the central maxima, 1, 2, 3, 4, and then fifth one. This separation is Y, which is given to us as 5 centimeters. Correct. Now, Meera, you tell me, what is this 1 meter given?
Capital D.
Capital D. Correct. Separation between the screen and the slit is 1 meter. 600 nanometer. What is it? Yes, Meera?
Wavelength lambda.
Wavelength is 600 nanometer. What do you have to calculate? Which variable? What is this? Which variable?
Small d.
Small d. Correct. Small d we need to calculate. So see, this has mentioned, this is the whole story of a bright fringe. Yes, Upasna, which formula should we use for bright fringe?
Y is equal to n lambda d by d. Capital D by small.
Capital D or small d?
Capital by small d.
Capital D by small d. From here, small d is missing. Rest of the 4 variables are given to you. Small d is will be n lambda capital D by small d. So this will be 5 into 600. Right now we have to write this nanometer as 10 to the power minus 9 because nothing else is given. But answer is in micrometer. So do have that in mind. Capital D is 1 and okay, this is Y. This is Y. Y is 5. So 60 micrometers. Right. Answer will be 60 only because see 5 will be cancelled. Yeah. Write it.
Done.
Done, ma'am.
Okay. Let's come to the next question. This is saying in a Young's double slit experiment, the slits are separated by 0.3 millimeters, right? 0.3 millimeters, and the screen is 1.5 meters away from the plane of the slits. It says distance between fourth bright fringes on both sides of the central bright fringes 2.4 centimeters. This means, see, you have to be very careful in this. This is saying this is the central maxima. I told you first, if this is the central maxima, then you have the first bright here, first dark, first dark. Both are first dark. Then after this, then you have the first bright and then first bright. Then again you have the first dark, like this. This is what I told you. So this is saying distance between fourth bright means fourth bright from here on both the sides and the lower one also, this one also, fourth bright. This separation is given as 2.4 centimeters. It is saying the slits are separated, means the separation between the slits is 0.3 millimeters. Capital D is 1.5 meters. N is given, yes, fourth. It is asking us frequency. For frequency, we require the wavelength. Basically, wavelength is missing. Upasna, you tell me what should be the value of Y that I should put here.
1.2.
1.2, correct. See, double the distance is given. We'll just take this 1.2 centimeter, and that's just a minute, class. The screen actually lags in between, so yeah. Is the screen visible now?
Yes.
Yes, ma'am.
Yeah. So Pastas answered it correctly. This is 1.2 centimeters only. This is 1.2 centimeters only. This is was double the distance given. Meera, what is the formula that I should take? Yes, Meera. Formula. Formula for the wavelength only. First calculate the wavelength.
Y is equal to n lambda d by
Same formula we are going to use. N lambda capital D by small d. From here, we are going to calculate lambda. Lambda will be Y d by N capital D. Now look, your frequency multiplied to this wavelength gives the speed of light. So basically for the frequency, divide everything with the speed of light. So it will be speed of light divided by wavelength is yd, and this nd will go up. So finally your frequency will be this. You can put speed of light is 3 into 10 to the power 8. N is given as fourth. Capital D is 1.5. Y is 1.2 centimeters. Na? So 10 to the power minus 2. And what small d given? 0.3 millimeter. 0.3 into 10 to the power minus 3, whatever answer you will get, this will be in hertz. But remember to extract 10 to the power 14 separately. In the question, 10 to the power 14 is separated out. So rest of the term that will be left, you have to write. Write it, then we'll discuss one more question.
Done.
Done.
Okay, see, this question says it's a question from your 6th September shift to 2020. A Young's double slit experiment is performed using monochromatic light of wavelength lambda. So wavelength is given lambda, and it is saying the intensity of light at a point on the screen where path difference is lambda is k, means intensity is this. So let's first find this relation. Second of all, it is saying that when intensity, you have to tell the intensity. When the wavelength becomes lambda by 6, intensity becomes nk by 12. See, this is the column for intensity and this is the column for the wavelength. Okay, this is the ratio what is happening. Now, class, intensity, in the intensities formula, if you remember, we had the formula as I1 plus I2. I1 plus I2 plus 2 root I1, I2 cos phi. So we don't have phi. So how will we get the net resultant intensity? So for calculation of phi, it has mentioned as the wavelength. Class, tell if the wavelength is given, if you have the wavelength as lambda, what will be phi? What's the relation? Check into your notes you've written. A relation I have made you write. A relation between the wavelength and this phase difference. What's it? This is delta x. Let me write it in a concise manner. See, the question says delta x is given and intensity is given. When it is lambda, this is I. When it is lambda by 6, it is nk by 12. You have to find out the value of. Yes. Yes, Upasna, you tell me. Phase difference and delta x. How do we relate?
Phase difference is 2 pi by lambda into path difference.
Yes, correct. 2 pi by lambda into delta x. So in the first case, delta x is lambda. So phi will be 2 pi by lambda into lambda. Lambda gets cancelled. Cos 2 pi, it's 1. So here we have cos phi will be 1. So if cos phi is 1, see, this intensity, we know it's I1, I2, right? So I net will become, intensities are given as I only. So this will become I plus 2 root I into I is 4I. 4I is equal to K. So let's keep it aside. Right now, this is of no use to us. We have to find out the second part where your path difference is given as lambda by 6. So yes, Meera, how will we proceed? What will be the angle according to you if delta x is lambda by 6 now?
5 by 3.
Pi by 3, correct. This will be 2 pi by lambda into lambda by 6, right? Lambda gets cancelled. This is pi by 3. So see, what's the net intensity? See, it's monochromatic. So we are taking single only. I plus 2 root I1 into I2 into cos pi by 3. So this becomes 3I. Now you know what is I. I is k by 4. So I is k by 4. So we need k by 12. So multiply and divide it by 3. See, multiply and divide it by 3. What do we get? 9k by 12. We get 9k by 12. So n is equal to 9. Got it?
Yes, ma'am.
Write it. We'll see some modifications of this topic only. Just write it first.
Done, ma'am. Done.
Okay, look, just one more topic. I think we'll not be able to complete this chapter today. Some portion will be left that I'll discuss tomorrow. Small portion is only left of polarization and diffraction. This says if two, see, now when two fringes, if the question says are coinciding, then use this formula. N1 lambda 1 is equal to N2 lambda 2 to get out the values of the fringes. This has come as a question. And if your entire setup of Young's double slit experiment is dipped into some other medium has changed, it is dipped into oil, water, anything, then divide the same thing, whatever you have solved for air, divided by the refractive index of that medium, you will get the fringe width. Okay. So this is one question. Let's see one question from this. It says in a particular portion of screen, 100 bright fringes are formed. Find the number of fringes formed on the same part of the screen if this whole setup is dipped in water. Refractive index is given. So means n is missing. The second n is missing. Right. Let's put the number as C. N1 is given to you. 100 bright, it is saying 100 bright fringes are present. And the refractive index it has given. The refractive index, right? So look, 100 bright fringes is the value of N1. So N2 is missing. This is 100. N2 is missing. Now for beta, we use the formula. Beta is equal to lambda, capital D by small d. See, capital D and small d, they'll remain constant. But anyways, let's leave it like this only right now. So n lambda d by d. We are going to multiply it with n, right? We will multiply it with n times number of fringes is asked. Though this is lambda d by d for a fringe width, we use this formula only. Now it is saying if the whole setup is dipped in water with a refractive index of 4/2. So now the new fringe width of this medium will be whatever is the fringe width in air divided by this refractive index, that is 4/3. Okay, so it's better if you directly take the ratio. See, the number of fringes when you have to calculate number of fringes, let's say second one, then you are going to use beta 1. Beta and n will be inversely proportional, the refractive index, right? Sorry, the number of fringes divided by the, let's say this is n1 divided by beta 2. Now beta 1 and beta 2, see, they are these lambda d, this capital D and small d are constant only. So instead of beta 1 beta 2, use lambda 1 lambda 2 whenever it is given. I'm just telling about a general question. Right now this question doesn't need that. Lambda 1 and lambda 2 directly. Now you have to relate this with the refractive index. So further use refractive index for this. Okay, use this formula whenever you have such kinds of questions and just extract whatever you require. Like here we don't know beta, we don't know lambda, we just know the number and the refractive index. We are going to use that only. Our, let's say the number of fringes will be divided by 100 will be 4/3 divided by 1. Right, refractive index of air, refractive index of medium, number of fringes. So use these formula because see, beta will be related with lambda and lambda is related to your refractive index. And the rest of the things which are coming in between, they are constant. So when you have the ratio, everything will be cancelled. So lastly, you will have these. Now, depending upon the question, like in this question, only these things were enough. So we just use this. You can calculate the value that will be that you can calculate later. What will be the number of fringes? 400/3 will come. Okay, is it clear, this part?
Yes, ma'am.
Okay, write down this.
Done.